Okay, we can use what we know about factoring to actually help us solve quadratic equations. If we'll think for just a minute what factored form looks like, it looks like x minus p times x minus q and sometimes there's a multiplier in the front. But there's always a multiplier in the front, but sometimes that multiplier is 1, so there may not be one listed. But my factored form looks like this. If my factored form were set equal to 0, we could apply something called the zero product property. The zero product property is very easy to understand. Think for just a minute what factored form means. Factored form, remember how we find it? We always go back to length times width of an area model. And factored form always has this multiplication going on between its parentheses. So it's saying that you've got something times something else, and that product is equal to 0. That's what factored form is expressing. So the zero product property says, well, hey, if you've got something that you don't know what it is, and it's timed by something else that you don't know what it is, but you do know that when you multiply them, you get an answer of 0, one of those values has got to be 0. So we feed off of that fact that if I've got a property set equal to 0, one of my factors must be equal to 0. So to begin to solve by factoring, I want to make sure that I'm set equal to 0, because the whole basis of solving by factoring is that I'm applying that zero product property. So I need to combine my like terms. I'll get my x's, my linear terms together. I meant for this to be a positive. Sorry. When I do that, I'm left with x squared plus 3x equals 4. I want to be set equal to 0, so I'll minus 4. Leaving me with x squared plus 3x minus 4 equals 0. Now that I've got it set equal to 0, we can factor it. So you want to look at this quantity over here, x squared plus 3x minus 4, and we want to factor that. So using my algebra tiles, I want to think about the factors of negative 4. That would have to give me 3. That would be positive 4. And 1. Positive 4 and negative 1, excuse me. So that one's got to be shaded. I'm going to arrange my area model that way. I do end up with negative 4 ones, which is exactly what I wanted. And those are also negative. Okay. So that factored form would be x plus 4 x minus 1. All right, now that I've got it in factored form and my factors are set equal to 0, I'm going to apply the zero product property. It says if these products are equal to 0, one of my factors must be 0. So I will say, okay, either the first factor is 0, which is x plus 4, or the second factor of 0, which is x minus 1. So I set both of those factors equal to 0. I'm trying to solve for x, so I would subtract 4 from each side on this problem. And I'd have a solution of x could be -4. And on this problem, I'll add 1 to both sides. And I'll have a solution of x is 1. Now, it's really important that I use that word or, because you think about the zero product property. You got two things that you're multiplying that could be 0. Only one of them has to be 0. It's an or situation. The first factor could be 0, or the second factor could be 0. Both of them could be 0, but it's not necessary. You only have to have one. So my solution, I would need to write it as x equals -4. And I'd want to put that magic word of or, because I understand what the zero product property means. Or x is 1. Both of those would be solutions to my problem. All right, if I look at my next problem here, let's erase some of this. This one is already set equal to 0, so I can go straight ahead with my area model. So I'll bring in my 2x squareds. Notice something for me here. We don't have a constant term, so I don't have to worry about having ones. I should still be able to do my area model. I just have to bring in -6x's. Now, I could bring in -6x's this way by decreasing my side by 3, since it's dependent upon 2. And those are negative, so I'll need to shade them. Or I could have put those -6x's this way. Could have done that as well. Either way, I'm going to end up with a factored form. There's two different expressions for that factored form. All right, so this direction is x minus 3. This length, I'm sorry. And this length is 2x. I didn't extend that side by anything. And there's my factored form. Applying my zero product property, I'll set each of those factors equal to 0. So I'd say x minus 3 equals 0. Here comes my magic word, or 2x equals 0. When I solve this linear equation, I get x is 3, because I'll add 3 to both sides. Or when I solve this one, I'll get x is 0, because I'll divide each side by 2. And notice how that magic word's coming with me each time. X equals 3 or x is 0. Okay? One more. This one we got to get into standard form, so let's get our like terms together. Let's do it all in one step. We'll take our quadratic term, put it with our other quadratic term. I can go ahead and combine that. That gives me 3x squared. Take my linear term, put it with my other linear term. Combine that. That leaves me with -5x. And take my constant term and put it with my other constant term. And then I've got it ready to factor. So now let's factor. We need to bring down 3x squareds. I need to think about, remember that 3 is affecting my 12. So I need to think about the factors of positive 36 that will add to give me negative 5. And I've got a sign wrong here. So this problem is actually not factorable. Let me explain that to you. That's important for you to know. I need my factors of 36 that would add to give me negative 5. And 9 and 4 pops in our heads automatically, probably. But if we're going to multiply and get positive 36, they either both need to be positive, which would give me a sum of positive 13, or they would both need to be negative, which would give me a sum of negative 13. So there's actually not a magic pair of numbers that I could manipulate with my signs that would get the product I want and the sum that I want. So this problem is actually not factorable. We're not saying that we couldn't express it in factored form, but it is not a factorable problem. So we couldn't solve by factoring here. And that happens sometimes with quadratics. We're going to learn a shortcut later for figuring out if it is factorable. But for right now, your process is to look for those factors. And if you can't find them, then you're not going to be able to solve by factoring. There are other methods that we're going to learn that we can use when factoring doesn't work. But it's important for us to be able to identify when that occurs. And that's it.